Yes. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yes, sir.
Yes, visible.
Yes, sir.
Fine.
Visible, sir.
Thank you. So yesterday we just had some introductory session. Just we will take 5 minutes what we discussed in the last class. What is GCP? Why GCP data engineer? GCP data engineer roles and responsibilities, various GCP data engineering products and services, job market of GCP. So we have got various cloud service providers. So data engineering on cloud, right? So we are using Google Cloud. So here nothing, no need to maintain any infrastructure, no need to maintain any teams, hardware team or OS team, operating system team or database administrator. So everything goes in the cloud premises. So yeah, various cloud service providers, GCP. We have got many service providers, but among that, GCP, Azure, and AWS are the major cloud service providers, which are mostly used. Most of the companies are using this, right? In that GCP, the growth of GCP is increasing at a rapid speed. Companies are migrating towards GCP. So here it is using the same kind of infrastructure that is used for that. Already you are aware about that Gmail, Google Drive, YouTube for all those, right? The same infrastructure Google uses for this. So why to choose GCP? Okay, I'll come back to this. So we see high availability of data from different regions, from different places it can retrieve the data from, right? Yes. Same. Easy to scale, increase or decreasing as per our requirements. So the web applications or data analytics or machine learning. So it has got wide scope of applications to run, right? So it is flexible. DCP is flexible. It can fit to any level of organization, like big or small. So here dividing, see, understand carefully in GCP, we have got GCP is providing 5 locations. Again, the 5 location is subdivided into 37 regions. Again, the 37 regions into 112 zones. Into how many? 112 zones. Okay. 5 locations, 37 regions, and 112 zones. See, in the 37 regions in India, we have got Mumbai and Delhi. Okay. So you may ask why to go for GCP, why not Azure or AWS, right? So it's the fastest, biggest network in the world, GCP. So it has got data centers throughout the world using high-end virtual machines, high performance, petabyte bandwidths. It separates both computation and storage. Yes, each cluster have got different number of nodes. Yes, pricing, flexible pricing. GCP is compared with Azure or AWS. Even discounted prices applied if you want going for long run workloads. Customization features available as per your requirement. Mm. Yes, scalability. Scalability, right? Easy to scale, easy scalability, easy to scale. Increasing capacity, increasing or decreasing, capacity increasing, capacity decreasing. Live migration is possible here in GCP. Whatever data is already available, we can migrate without impacting the existing data. So big data, and so we have got many predefined machine learning and big data APIs in GCP, and also like free trials. Some services are free for lifelong, some services are free for 1 year, some are free for 3 months. Customer systems migrations, right? Existing data migrations to GCP. So from 20 years, if you are running a business and you are storing the data in that on-premises databases, migrating to GCP is very simple and easier. Okay. So here, generally I said, right, data engineer as compared with that ETL developer. Previously, we got ETL developer. We have got a lot of responsibilities like for data engineer as compared with the traditional ETL developer. So this data engineer should be able to work with all varieties of data, all types of data, structured data, unstructured data, semi-structured data. Mm. He should be able to work with NoSQL data, streaming data, which keeps on generating, right? Yes. And he need to work with the data, handling, extracting, storing, filtering, transforming, processing, merging, sorting, grouping, analyzing, right? He's going to do various transformations. Okay. Extracting data from different sources, processing it, and finally taking the data to the destination. So for smooth data flow from the source and destinations, data engineers are responsible. They work with the cloud services and make the data structured and useful. Data engineers, they maintain entire organization's data infrastructure. So why GCP data engineer is in demand? Role of a GCP. See, GCP data engineer, right? If you see any organization, we have data engineer and data scientist will be available. Data engineer made responsibility. He creates data warehouse for the organization where he's going to store that data, right? He makes the data structure, stores it, right? And he monitors the data, maintains data security. The data has to be secure in each step of the process without any data leaks or data exposures. Okay, the main role is for creating data warehouse, for storing for different, pulling the data from different sources. ETL, extracting, transforming, and loading. This is one of the key tasks of data engineer. Data monitoring, monitoring at each step of the process without any data leaks or exposures, and see that data is available at each step of the process. Data security, this is also one of the important step. So without any data leaks, designing, building, and maintaining data pipelines. You need to have some kind of analytical skills, right, to do that analysis. And before that, right, I was also briefing like in case of data science, we perform data analysis predictions. Here in data engineering, data management, data storage, and data processing. In case of data analyst, data visualizations. Okay. So GCP, if you talk about the GCP, right? Cloud platform, GCP cloud platform. So here, it acts as a platform as a service, infrastructure as a service, right? A GCP data engineer, right, ensures data quality, optimizing data storage and data processing. Yes, monitoring data infrastructure. Okay, okay. I was talking about the various data engineering products or services. So I'll be briefly discussing about this. So here, Google Cloud Storage, GCS. Google Cloud Storage, GCS, for storing the data. Here we store data in the form of buckets. In the buckets, we'll upload files. BigQuery for fast querying, storage, analysis of large data sets. Dataproc for big data processing and analytics. Databricks for PySpark processing in GCP. Dataflow for stream and batch data processing. Cloud Composure, Apache Airflow, right? For automating and monitoring data pipelines. Pub or Sub for messaging and data ingestion. For messaging and data ingestion. Okay. Okay, these are the major data engineering products or services I'll be discussing. Okay. So, and before that, see that what this observe this diagram I have drawn in the paint. Check it. So, if we talk about the compute majorly, if we talk about this GCP cloud infrastructure, right? Okay. The Google Cloud Platform products can be categorized into four categories. GCP products can be categorized into four categories: compute, storage, big data, machine learning. Each category has its own set of products. If I talk about compute, here we have got App Engine, Compute Engine, Container Engine, Cloud Run. So here, compute engine, right? If we talk about this compute engine, running running large scale workloads, running large scale workloads on virtual machines hosted on Google's infrastructure. Container engine runs Docker containers on Google's infrastructure. It's powered by Kubernetes. App engine platform for building a scalable web applications and mobiles applications, right? Yes. When Cloud Run fully managed compute from fully managed compute platform for deploying and scaling the applications, for running the applications quickly and securely. Apart from this Cloud Run, we have also got Cloud Functions. Cloud Functions also available, a serverless platform. So which will building event based right? Microservices kinds of events in GCP. So okay, storage. If I come to the storage, right? Cloud storage, Cloud SQL, Cloud Spanner, Cloud Firestore, Bigtable, BigQuery. In that, which are relational, which are non-relational, right? Which are relational, which are non-relational. So cloud storage is object, and Cloud SQL, Cloud Spanner are relational database. Cloud Firestore, Bigtable are non-relational, no SQL type, and BigQuery is data warehouse. So here, okay, cloud storage. So it is um, for storing different types of images, medias, data, right? Yes. Cloud SQL, good for web frameworks, for e-commerce, and even if you talk about Cloud Spanner, RDBMS, and for user metadata, AdFin, right? Cloud Firestore, Cloud Firestore for hierarchical mobile networks and webnet, web communications. Bigtable, right? Bigtable for heavy read and write, operations. BigQuery for enterprise data warehouse. BigQuery is for enterprise data warehouse, for analytics, for dashboards, right? And coming to this big data, Dataproc, Databricks, Dataflow. Just now I was talking about these things, right? So, so this document file store is there. Document file store to handle document type storage. We have got different types of storages: key value store, graph store, document store, column store. But cloud file store is kind of a document store. So this big table also supports key value pair. And this Cloud SQL is ease of migrating compatibility for traditional databases like MySQL, Postgres, SQL Server, right? Yes. If you talk about this Google Cloud Storage for storing and managing data, like files, it can be images, it can be videos, it can be data is stored in the form of objects here. So, like here we have buckets, Right. In the buckets, we'll be storing the files. So we have got many storage classes. Later, I'll discuss in brief different types of Google Cloud storages, and even data proc. Data proc is a kind of Spark. It is a kind of managed Spark and Hadoop service. It is a Spark and Hadoop service that lets you the advantage of open source data tools for batch processing, querying, streaming. It is a kind of data block automation. It helps in creating clusters quickly, right? And if you talk about, so I said for big data processing, right? How big data projects were handled, right? Big data projects were handled. So, big data, if you talk big data, if you talk big data technology, they use model like distributed computing. They have brought a kind of revolution in case of distributed computations, right? Even if you talk in data bricks. So here we use data bricks like PySpark processing. So here within this data bricks, we'll be using like PySpark. Py is nothing but Python API for using Spark. Python API to use Spark. So here, if you talk about that, PySpark is also currently, if you see in this, we'll be discussing, I said, within our course. It's a lightning fast technology that is designed especially for kind of fast computation. So PySpark, that is and Databricks, right? But it has a demanding tool among the data engineers to work with bigger data sets. So using that PySpark, we can run distributed SQL. We run distributed SQL, right? Data stored across multiple systems processed, and using that PySpark Databricks, we create data pipelines, ingesting data into a database, running ML kind of algorithms. Spark ML is there, working with graph kinds of algorithms, working with the data streams. So if you talk about this Databricks, the PySpark in due to the in-memory computation, storage and processing, both happening in the memory level. Parallel processing, you'll be seeing distributed execution, you'll be seeing lazy evaluated on demand, you can execute the flow. Okay. If I talk about this Databricks, if I talk about this Databricks, right? For example, Databricks. Assume assume a cluster of 100 nodes. This 100 nodes cluster is worthy. It is worthy processing 1 TB of data, 1 TB of data at a time. Tomorrow your data volume increased. Assume tomorrow your data volume increased. Processing 1 TB of data at a time. Tomorrow your data volume increased by huge amount. Increased by huge amount. If same cluster used, if same cluster, see if your data is increasing means your cluster capacity also. Cluster means cluster capacity means Cluster has got multiple systems, multiple nodes. If data increases, your number of systems also has to increase. Speed goes down. Speed goes down. Solution for it. Solution for it. Scaling up the cluster. Scaling up the cluster. Adding 50 new nodes systems. So scaling up the cluster by adding some 50 new nodes. Again, after 1 month, again after 1 month, again 50 nodes added. Again after 1 month, 50 nodes added. So every time, whenever the data is increasing, every time I need to increase the systems, number of systems, right? Every time scaling up physical data centers. Physical data centers is a complex task, So the solution, same cluster in the cloud, same cluster in the cloud, and that too, auto scaling feature. So the solution, same cluster in the cloud, and that too with auto scaling feature. Who is providing? Who is providing this? Databricks. Who is providing this? Databricks. Databricks. Spark Cloud Cluster with auto scaling feature. Example, today your organization data load requires 100 nodes, 100 systems. Tomorrow your data volume increased. It has to be extended to 150 automatically. It has to be extended to 150 automatically. After processing is done, again it has to revert back to 100 nodes. This is Databricks. Here, who is processing? Here, PySpark is the main. Here, PySpark is the main processing engine. It is a very high speed. It is a very high speed processing execution model. Which process huge data, which process huge data at quick time, which process huge data at quick time. So here PySpark I'm talking, here we'll be discussing that is 100 times faster than normal disk processing. Normal disk processing. If you observe, lot of tests were done already to see the speed, right? Okay. Yahoo has conducted a test. Yahoo has conducted a test. It has taken a table of 100 TB data consisting of 1024 columns. Yes. Task sorting. Sorting based on 16 columns. Sorting based on 16 columns. Sorting based on 16 columns. What is the time taken by? Time taken by different things, right? So if you talk, Oracle has taken 3.5 days to process. MySQL has taken 6 days. Specialized databases used for data warehouse like Teradata has taken around 4.5 hours. And the specialized database used for data warehouse, Netija, has taken around 3 hours. And finally, like a big data Hadoop, it has just taken 3.4 minutes. 3.4 minutes, right? These have taken days of time. These have taken hours of time. This has taken minutes of time. So here, but if you take Hadoop, taken of minutes, these have taken days and hours, but Hadoop has taken minutes of time. But Spark is 100 times faster, 100 times faster than Hadoop. In Hadoop, we have got a map reduce execution, MR we say, map reduce execution. So it is 100 times faster than Hadoop. Then you can see if it has Hadoop has taken minutes of time, when Spark is 100 times faster than that, then you can see the spark of the speed of Spark. Means here we say PySpark in our case. Spark with Python implementation, we say like PySpark. See the speed, it is a very high speed, right? So here, okay, that is what Databricks PySpark, right? So here in case of PySpark, we have got MPP, massive parallel process. Here, massive parallel process is going to happen. Data is distributed across multiple systems. Multiple systems will be processing parallelly. Parallel processing you are going to see. So here, as part of this course, so here we'll be building data pipelines to get data from multiple sources into data lakes or data warehouse, and then the data lakes or data warehouse to downstream systems. Yeah, part of this course will walk through the how to build a data engineering pipelines using GCP data analytics. It includes services like Google Cloud Storage, Google BigQuery, GCP Databricks. So apart from this, environmental setups to learn about this VS Code, and also once environment setup is ready, we'll be signing up for Google Cloud account. So cloud account including billing, right? So you'll be getting some USD $300 credit once you get the free subscription. Once you go for free subscription, you'll be getting $300 credits will be added to your account. In Indian rupees, around 26,000 rupees you'll be getting, right? You can work within 3 months, 90 days of time. So no need to go with paid account or pay as you go account. Just to go with this free account is more than enough. So we'll be using cloud storages, right? As data lake, as part of this, how this Google Cloud Storage data lake, how to manage the files in this Google Cloud Storage using commands as well as Python, and integration of different things with files, and also providing some kind of RDBMS service. GCP is providing GCP is providing some RDBMS service like Cloud SQL. How to set up like databases like Postgres database server using Cloud SQL, and also I'll also show you one more RDBMS like MySQL also, how you can set up it using Cloud SQL. Once the database server is set up, you will take care about setting up applications, database, and user. And also some kind of applications integrating GCP secret manager for retrieving the credentials. So we have got a BigQuery like for data warehousing, data warehouse operations, our key integrations with other things. And also like we need to process heavy volumes or huge data, which is also known as big data processing. For huge data and for big data processing, just before I was talking like GCP data proc. It's a big data service with Hadoop, Spark, and Kafka. You will not only learn how to set up this Dataproc cluster, but also like how to use the single node Dataproc clusters or this for the development and developing environments with the just like US code, VS code environment with remote connection to the Dataproc cluster. And understanding this big data processing using Dataproc and building ETL, end-to-end ELT. Generally, ETL is for small data, ELT is for huge data. So end-to-end ELT data pipelines using Dataproc workflow templates. And also how to build ELT pipelines, right? ELT, ETL is for small data, ELT is for huge data, I said, using Spark SQL. And later, like another like how to get started with Databricks on GCP. This Databricks also, see here, takes care of building end-to-end ELT data pipelines using Databricks jobs and workflows. And how to integrate these two services by building end-to-end ELT data pipelines using DataPro workflow. How to include PySpark-based applications in BigQuery with the Spark BigQuery connector as part of this. So with many real-time use cases I'll be discussing. So here you'll also be discussing about this application development lifecycle of Spark and what are the issues all related to the Spark, like using web interfaces like Yarn. Okay. Now check it, right. In the last class, I was just briefing you about this. And once you can check this course content. So these are the major discussions, right? GCP data engineer, Google Cloud Storage, GCS, Cloud SQL setting up database, BigQuery for building data warehouse, Data Proc for big data processing, Data Bricks for big data, PySpark processing, Data Flow, Apache Beam, and the Google Cloud Composer orchestration, Data Fusion, Data Integration Service, DBT, Airflow, Terraform. So here you can once go to the syllabus, how brief, how depth will be going, right? GCP, data engineering, fundamentals, storage and databases. GCS, Google Cloud Storage, what all the things we'll be discussing. Cloud SQL, what are the things we discussed? Data ingestions, integrations, data warehousing and analytics. BigQuery for building data warehouse. Data proc, big data processing. Okay. ELT data pipelines using Dataproc, Databricks PySpark processing, ELT pipelines using Databricks, integration of Spark on Dataproc and BigQuery, data flow, PubSub, Google Cloud Composure, data fusion, data cloud functions, Terraform, data pipelines using dbt, Airflow, and BigQuery. Machine learning in GCP, security monitoring and governance, real world data engineering scenarios. Okay. So I said the offerings from my side. You will be getting live video recordings, clear soft copy of this class notes, assignments and tasks to work, a WhatsApp group for technical discussions, or if you got any errors, you can take snap and post, and interview questions, around 100 interview questions, live interactive hands-on sessions. Okay. So you can do the things, the tasks, if you can do parallel along with me, whatever task, right? You can do along with me parallelly. If you got any error, if you got struck up, you can share the screen in the Zoom. All the sessions I want interactive, and you should maximum try to do it parallelly along with me. Duration around 10 weekends, 10 to 12 weekends, right? 10 to 12 weekends in brief. Saturday 2 hours, Sunday 2 hours. Sometimes I'll be increasing if you are working with the practical part, if it is unfinished. So it's an offer batch. The course fee is just 10,000. So GCP data engineer has got a great boom today. So becoming a cloud data engineer. So if moving to this environment, this is the correct time for you people, like data engineer and data scientist. These are the two technologies which are running in the industry from the last. If you talk from last 1 year, the survey is saying data engineering jobs roles have increased by 28%, and data science and AI job roles increased by 36%. So there is a increasingly in demand for this data engineer skills. Companies are digitalizing their solutions to transform how to do that business. And here top, okay, if you talk like kind to the pay scales also, right? Data engineers will get the highest salary packages as compared with the other things. Okay, for other technologies, even if you got if you'll be getting great command by the end of this course, you can also demand for the salary. Means if you've got good command on these technical skills, so even the two highest paying jobs, data engineer and data scientists. So in the companies, if you talk, they're offering high paying jobs for this data, especially GCP data engineers. If you have got the right skills, you'll be that. And if you got command on this, definitely you can go through the process. Okay. So attending the sessions regularly, doing the practicals and assignments tasks properly, right? Regularly, just you'll get confidence here. So from the next Saturday onwards, we'll be starting with the actual things. I'll be showing you how to get the subscription and total that portal, GCP portal, right? Total overview about that portal I'll be providing. A free subscription for 3 months you'll be getting for 90 days, which is more than enough for you. Don't go for paid account or pay as you go account. Yes. Any other queries you got? Two projects I'll be discussing as part of this for getting this practical exposure. Hmm. Any other queries, anyone? Right. Next Saturday onwards, we'll be starting with the actual things. So next week, next Saturday, the link will be changing. You are supposed to get enrolled to get that link. Link you'll be getting to your mail. And you can see a message given in this chart. You can see a big message in the chart, right? In the Zoom chart, you can see a message given by this online team. The course content details, their contact details, and the payment details, right? And just check with that. And yesterday, if anyone absent to the yesterday, the demo video of yesterday also is given here. Okay, fine. Any other queries, anyone? Right. Okay. So, if I'm, so thank you all for your time. So I'm signing off for now. Meet you from next Saturday. We'll be starting with the things. You can do the things parallel along with me from next week onwards. So, fine. Bye, everyone.
Hello, sir.
Yes, yes.
Sir, what is mean by cluster, sir? Like you said, cluster and nodes.
See, cluster is like, but see, generally systems which are interconnected. Such systems which are interconnected. Say a group of systems which are interconnected, we call it as a cluster. 30 systems or 20 systems which are interconnected in a forms a cluster.
Sir,
Data
what?
is
Yes, sir. Yes, sir. Sorry.
data is going to see generally a simple labor example if I give. If you are if a building construction, if you are keeping on, if you have got more number of labors, then the work goes fastly. If only one person doing the entire thing, it goes very slowly. In the same way here single system distributed computation. Here we go with multiple systems, multiple. If any job is there, the job will be dividing into task. The task will be given to multiple systems. They'll be running parallelly and will be processing the things parallelly. That's why distributed and parallel processing. Data will be distributed across multiple systems and data is processed by multiple systems parallelly. That's why we see very high speed. All that happens internally. We no need to do about it. So your data, if huge data, petabytes or terabytes of data divided into multiple partitions stored across multiple systems and processed and provides you the results, what happens internally. Okay.
Again, you said number of nodes. You said. What does that mean, sir?
Number of nodes, systems, machines are same. Nodes are systems are machines. Group of systems, group of nodes, group of machines, which are interconnected. So if you've got more number of systems, more number of nodes working for a particular job, right? So they all are working parallelly, they are processing parallelly. So you see more speed. So work done by multiple labors, work done by single labor, you can see much difference, right? If you more systems, the more speed. Yes.
Uh, Thank you, sir.
Okay. So I'll be explaining all these things. So it's a demo session. I cannot do all the architectural parts here. So once we enter, we'll be step by step. I'll be discussing about those things. Okay, fine. So any other queries, anyone?
Sir, like I'm new to this field, sir. Like I'm non-IT background, sir. So if I get any queries, so how to?
So that's why, right, especially for all my batches, I am myself creating a WhatsApp group where you can ping me personally or in the group or during the sessions you can ask the queries, any small session, any small query or anything you can ask during the session. Or we have group for technical discussions. If any errors, take the snap and post in the group, or still if anything you do along with me parallelly the task so that you will be understanding the things. And if any error, immediately you ping me, just I'll ask you to share the screen so that it will be rectified, right?
Yes, sir. Yes, sir.
So it's all do you are doing everything in the cloud. People will be seeing how I can. So do it parallel along with me, step by step. You will be getting the output. You will be getting exposed to the tools. You'll be doing what you how you are performing everything. It looks simple only. It's not. So it's one of the in-demand tool, right? This data engineering, right? Within a cloud, that's got high demand in today's market. Even if you see, even if you got good command, you can ask for uh, 100% hike also, right? That is a kind of this is what other kind of technology, right? It demands, you can also demand for the package or the salaries. So today, like data engineering and data science and AI has got great demand in the market. But if you go for data science or AI, lot of things like a research oriented way you need to go. But here we are just going for data management, data storage and processing. We are not performing any analysis or predictions. So there you will see a lot of mathematical things, right? Analysis, statistical analysis, machine learning, deep learning, you can see a lot of things. But here it looks simple only. Only thing is regular to the sessions, practicing after the sessions. If any queries, you can ask me at the start of the session itself. I'll be discussing it. If it is taking time, I will give separate time for you for the queries, right? Yes. Okay.
Yes, sir.
Fine.
Thank you.
So, yes. Okay. So if I'm done with the queries, if there are no other queries, I'm signing off for now. Meet you on next Saturday, right? So just get enrolled for getting the link, and next week you'll be added to the WhatsApp group. You'll be getting the videos to Google Drive. Clear notes you'll be getting to your mails, right? Thank you all for your time. Thank you. Bye.
Yeah, thank you, sir.
Fine.